Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem in which we have to solve the differential equation this. So, we have given this differential equation. So, look at this how I will approach. So, we have x dx plus y dy equals x times x dy minus y dx. So look at the idea how I will try this question. So the point is, first I will try with variable separable method. Okay, means we will try to keep x thing together and y thing together. So if you'll observe, look at this. Here x and y are engaged. Here also same problem, and we cannot segregate x and y. Okay, you will always struggle to handle this situation. Now what we will do, we will apply first filter of variable separable method. So the idea is, the first filter was dy by dx equals to linear. It is not in that form either. Then second filter was uh, dy by dx equals to linear by linear. You cannot convert this question into that form either. Then we have third form, polar, है ना? So in polar you must have read that, like when we will decide that we can apply polar form, if we will observe x dx plus or minus, sorry, x dx plus or minus y dy, correct? Hope you remember this situation. Now if you'll observe this question, we have x dx and y dy together, so we can apply polar form over here. Okay, now you also know that previously we have studied that if we have x dx plus y dy, we will be using sine square theta plus cos square theta equals to 1, correct? Over there we have extracted two information, that is x dx plus y dy is equal to r dr, and the second information was x dy minus y dx is equal to r square d theta. So these are the two informations that we have extracted while dealing with sine and cos. So let's handle this part in this order only. So the idea is x dx plus y dy will be replaced by r dr. Okay, so we got r dr. Now we have x thing, correct? So who was x? X was r cos theta, correct, है ना? And we have x dy minus y dx, so that is r square d theta. Okay, so this is the point. Now what we have to do, we will neutralize this and this. Now if you'll observe, you can segregate r and theta. So we have dr by r square equals cos theta d theta. Now we can do integration both sides. So we can write this question as r power minus 2 dr. Now do the integration. So r power minus 2 plus 1 is minus 1 upon minus 1. Done with this integration. And then we have integration of cos theta. Integration of cos theta is sine theta plus integration constant c. I hope the idea is clear. Okay, now look at this. Can I write this thing as this part? Can I write this part as 1 by r, that too with minus sign, and then sine theta plus c. Now let's write down the final thing. You know that they have given you question in form of x and y, not in r and theta. So now you have to backtrace your original thing. Okay, so you know that you have used x square plus y square equals to r square. Hope you remember sin square plus cos square equals to 1 है ना. Here for x you guys have used r cos theta whole square plus r sin theta whole square equals to r square. Okay, now look at this. In place of r, can I write this thing as minus of 1 by root over x square plus y square? So this is your r. Now we have sin theta. Look at this. Do you remember that over this case only you have calculated tan theta? Correct? Tan theta was what? Y by x. है ना? So can I write like tan theta was y by x. So can I write theta as tan inverse y by x? So can I write sine? I will require more space. Wait a moment. Okay, so we have sine tan inverse y by x plus integration constant c. I hope the idea is clear and you guys can handle similar situations. So see you guys in next session of MathFlix.